In this lesson, we're going to use the sine and cosine ratios. The sine and cosine are the trig ratios for the acute angles that involve the lengths of a leg and the hypotenuse of a right triangle. So if my reference angle were A, then the sine of A would be opposite over the hypotenuse. And the cosine would be the adjacent over the hypotenuse. So again, the sine is opposite over height, and cosine is adjacent over hypotenuse. So if I change my reference angle to B, this now becomes opposite, and this now becomes adjacent, so that the sine of B would be opposite, which is AC, over hypotenuse, which is AB, and the cosine would be adjacent, which is BC, over hypotenuse, which is AB. And if you take note, the sine of the one angle is the same as the cosine of the other. The cosine of one angle is the same as the sine of the other. Okay, we're going to find our sine ratios of R and S. So if I reference R first, here's opposite adjacent height. So the sine of R, opposite over hypotenuse, most reduced form, and then decimal, 4 places. Then the sine of S, the opposite is 20 over hypotenuse. And 4 decimal places. So you should try 3, doing your sine of R and sine of S. Then we move on and try cosine. Cosine is adjacent over hypotenuse. So if I do the cosine of A, adjacent over hypotenuse, most reduced fraction form, and then the cosine of B, so the opposite of, or the adjacent of B is 20. So once again, you should try number 9 and check your answer. And we can use cosine and sine to find missing lengths, and that's what we're going to do in this next section. Only using cosine and sine. So the first step to do that, if you take notice that we have our angle, we have opposite, adjacent, hypotenuse. So the first thing we need to find is h. So to find h, I have the opposite, so that would be the sine equals opposite over hypotenuse. It's in the denominator, so we divide. And now that we have the hypotenuse, we can use that to find a, which uses the adjacent cosine. It's in the numerator, so we multiply. And you should do 15. It would work in the same manner as 13. If your angle, you have the opposite, find the hypotenuse first, and then find the adjacent. And in our last section, we are going to find the unknown side length first, and then find the sine and cosine of a, writing as a fraction and decimal to 4 places. So find the missing side length, giving 2. We learned this in the first section. We can use the Pythagorean theorem. So to find h, in this case, hypotenuse, it's going to be the square root of, since we're trying to find the hypotenuse, we add the squares of the other 2 legs. And when we do that in the calculator, we get 65. Since I'm only referencing a, we have opposite and adjacent here. So the sine of a, opposite over hypotenuse, cosine, adjacent over hypotenuse. And you should try 23. It's rational numbers, so it isn't too bad. Except this time, you're finding the adjacent So you want to make sure that you recall when you're finding one of the legs, it's the hypotenuse squared minus the leg squared, and then take the square root. Then when you find the sine, the opposite is 36, and you just found the hypotenuse. Oh, sorry. I did that earlier too. We just found the adjacent. It's a common mistake. 85 is the hypotenuse. And then the cosine is the adjacent, which we just found. So it's very easy to get confused. Examples use irrational numbers. Still done the same way, you just have to be very careful in what you do as far as putting it in the calculator. So the first one, we are finding the hypotenuse. So it is the square root of the sum of the squares. So when you put this in the calculator and you put your first parenthesis in, then your square root. If you're using my calculators, I'm almost positive it puts another parenthesis in there. So you have to close the square root parenthesis and then put another one to close the first one, then square it. Otherwise, you're going to get wrong numbers. So then the sine of A, the opposite over hypotenuse, reduce, square root's in the numerator, so that's fine. Cosine, adjacent, so once again, you should try the last one. And once again, you are finding the opposite, or one of the legs, instead of the hypotenuse. In the last part of this, it's just a nice summary. You should put this to memory. The sine of an angle is the opposite over the hypotenuse. Cosine is adjacent over height, and tangent is opposite over adjacent. And that won't be given to you. You will have to know that, and you will not be able to have a little cheat card for that section, sorry. And this concludes our trig functions or ratios of sine and cosine.